Let's try to understand the Lewis structure of a sulfate ion. A sulfate ion or sulfate ions are usually found in sulfuric acid. It's SO4 2-. There's one sulfur and 4 oxygens with a 2 negative charge. So in the first step, let's write the valence electrons or show the valence electrons of 1 sulfur and 4 oxygens. So since both sulfur and oxygen belong to group 6 on the periodic table, so they have 6 valence electrons. So sulfur has 6, oxygen also has 6 valence electrons. So altogether that is 30 valence electrons, and you see 2-, that's the total charge on this ion. So which means there are 2 additional electrons on sulfate ion. So altogether we have 30 plus 2, that's 32 electrons. We need to show, or we need to distribute 32 electrons around 1 oxygen and 4 sulfurs. How do we do that? Let's take a look at this one. So we have sulfur in the center, and we have 4 oxygens surrounding the sulfur. There's the third and the fourth oxygen. So we need to distribute 32 electrons. So let's start with 2 electrons each. Right. That's 4, 6, 8. So out of 32 we have distributed 8 electrons. Now we have 24 remaining. So I can show the remaining 24 electrons as non-bonded electrons. These electrons don't participate in the bonding. So that would be 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and 32. Now let's take a look and see if this structure is correct. So if you look at each of these atoms, they have 8 electrons. This oxygen has 8 electrons, that oxygen has 8, this oxygen has 8 too, that oxygen also has 8, and the sulfur also has 8 electrons. So each atom is stable, but do they have the right amount of charge? So altogether the total amount of charge on a sulfate ion is 2-. So let's take a look at this. This oxygen originally has 6 valence electron, but whereas here it has 2, 4, 6, and 7. So it has 1 additional electron. Similarly, this oxygen also has 7, 2, 4, 6, and 1, 7. This oxygen also has 7 electrons, so that gets a negative charge. This oxygen also has 7, that gets a negative charge. So each of these oxygens have 1 electron more. That's why we have shown this negative charge. So according to this Lewis structure, the formula of a sulfate ion is SO4 4-. That's not correct. We want an ion with a double negative charge, which is 2-. So that's not correct. So we need to get rid of 2 additional negative charges. How do we do that? Well, you can move a pair of electrons on this oxygen between sulfur and oxygen. So that becomes a double bond. Also, to get rid of another negative charge, you can move a pair of electrons from oxygen to or between sulfur and oxygen. So in total we moved 2 pairs of electrons to convert those 2 single bonds to double bonds. And let's see if the resulting structure is correct. So that bond is this is going to be a double bond now. So now oxygen has only 4 electrons around it, right? And this is a single bond that doesn't change. That has nothing to do, we haven't changed anything on that oxygen, whereas this oxygen becomes the bond between this sulfur and oxygen becomes a double bond. So there's only 4 electrons around this oxygen now, and we haven't made any changes to this bond, so that remains a single bond. So I'm just writing as it is, right? So that has a negative charge because it has 7 electrons, and this oxygen also has 7 electrons, so that gets a negative charge. Whereas this single bond became a double bond, that single bond became a double bond. So you can move, to get rid of these two additional negative charges, you can move a pair of electrons from this oxygen, this, or this, or this. It doesn't really matter which electrons you move. Our goal was to get rid of two additional negative charges. That's what we did. Now let's take a look at this and see if this structure is correct. First, let's count to see if each atom has 8 electrons. So that oxygen has 2, 4, plus 4, 8. This oxygen has 8 electrons. That oxygen also has 8. This oxygen has 8. But surprisingly, you see sulfur has more than 8. That's 4 to 6, 4, 10, 12. Sulfur has 12 electrons. But it doesn't matter. So sulfur can accommodate more than 8 electrons. It's a bigger atom. So if it has less than 8, that's a problem. But if it is more than 8, some atoms are bigger, so they can accommodate the additional electrons in its atom. And also, let's see, so each atom now has 8 electrons here. Let's see if the charges are correct. So altogether, that's -1 plus -1. So the total charge on our sulfate ion is -2. So that matches up with the charge on the ion. So that structure is correct. So in other words, in a sulfate ion, there is 2 double bonds. That's a double bond, that's a double bond, that's a single bond, and that's a single bond. So the oxygens forming single bonds are the one that have a negative charge. So you can show the remaining non-bonded electrons in this fashion. This is only 4 electrons because it gave a pair to make that single bond double. This oxygen has 7, so that gets a negative charge, whereas this oxygen has only 4. So that's what a sulfate ion Lewis structure looks like. So there are 2 double bonds and 2 single bonds with a total charge of 2 minus.